The race for greener skies is on, but how green is green? Welcome to this episode, where today we're delving deep into sustainable aviation fuel, or SAF. Is it the eco-friendly solution we've been waiting for? Let's find out. Global aviation leaves a significant carbon footprint. Currently, aviation accounts for around 2.5% of global carbon dioxide emissions. However, its overall contribution to climate change is higher. David Lee and his colleagues quantified the overall effect of aviation on global warming to be 3.5%, when all impacts were included, such as water contrails. So, what can we do to reduce the impact of aviation on global warming? Sustainable aviation fuel is crafted from renewable resources like cooking oil and bio-based material. It promises lower life cycle carbon emissions than traditional jet fuel. But let's unpack what this actually means. Various chemical technologies are utilized in the production of sustainable aviation fuels. One such method is the Fischer-Tropsch process, where a mixture of carbon monoxide and hydrogen, derived from biomass gasification, is transformed into liquid hydrocarbons. Another breakthrough technology is hydroprocessed esters and fatty acids, or HEFA. This process involves hydroprocessing of fats, oils, and greases, converting these triglycerides into paraffinic kerosene. Another technology, electrofuel production, is applied to store energy from renewable sources in the chemical bonds of liquid or gaseous fuels. Alcohol-to-jet, ATJ, is a process for the conversion of alcohols to an alternative jet fuel blend stock based on catalytic steps. As of now, the global production capacity of sustainable aviation fuel remains a drop in the ocean compared to conventional jet fuel. According to the International Air Transport Association, IATA, SAF production tripled to some 300 million liters in 2022. US production reached 15.8 million gallons in 2022. But it accounted for less than 0.1% of the total jet fuel used by major US airlines. The EU has set ambitious targets for sustainable aviation fuel production. Fuel suppliers must ensure that 2% of fuel made available at EU airports is SAF in 2025, rising to 6% in 2030, 20% in 2035, and gradually to 70% in 2050. But how much sustainable aviation fuels could be produced with the current technologies? Jane O'Malley and her colleagues estimated in their paper that there is a sufficient resource base to support approximately 3.4 million tons of SAF production annually, or 5.5% of projected EU jet fuel demand in 2030. The limited resource base for producing SAF suggests that bio-based SAFs alone cannot decarbonize aviation in the EU, and will have only a limited impact through 2030. Based on their modeling work, they estimated that electrofuels will largely remain cost-prohibitive without very high policy support through 2030 due to the combination of high electricity consumption of this pathway. According to the authors, even with strong policies in place, the limited availability of the best-performing feedstocks suggests that SAF production alone cannot achieve the EU aviation sector's long-term GHG reduction obligations. Is sustainable aviation possible, or is it just hot air? The answer is unfolding right before our eyes. SAF represents a significant step towards a greener future for air travel, but it's not the sole solution. As we navigate the complexities of sustainability, it's clear that a multifaceted approach is needed. This includes not only advancements in fuel technology, but also in aircraft design, energy efficiency, and even changes in travel behavior. While SAF currently has its limitations, its evolution and increasing adoption are crucial pieces in the puzzle of sustainable aviation. It's a journey of innovation, commitment, and global collaboration. The skies of tomorrow may look different, but they promise to be cleaner and more sustainable. So, is sustainable aviation achievable? Absolutely, and it's up to us to build and support the pathways that lead there. Don't forget to subscribe, share, and fuel the conversation. See you soon in our next episode where we continue our science and technology journey.